Section 4.1 PDF for a discrete random variable. So with this section, we're going to do is just take and the sample space given up above, we're going to take that information and fill out the table below. One thing to consider is that in this example, the sample space is already provided, but in future examples, you'll have to create your own sample space. For this one, we have 4 coins being flipped, and recognize that we have 2 sides on a coin, and a lot of times they call it a fair coin, so that we understand it's 50-50, or the probability would be 1/2 would be the same for either side. So if there's 2 sides and we're flipping the coin 4 times, again it's going back to the idea of a multiplying effect. So in this case here, if we had 4 coins being flipped, then for each one you have 2 ways for the first, 2 ways for the second flip, 2 ways for the third flip, and then 2 ways for the fourth flip. By the fundamental counting theorem or principle, that we know to multiply those all together. And the reason why we do that is that we get 16 ways total. And I'm pointing this out with a multiplying effect here because down here in our sample space, we see that we have 16 outcomes. So I want to point out that this is the sample space. And kind of think of it as your population. This is the set of all outcomes in which we draw our events here, and the events that we will be looking at is X, that we have, and here in the point of view is the heads. So if we have 0 heads, 1 heads, 2 heads, 3 heads, or all 4 heads, what's the probability of the following? Let's start off with the first one at 0 to fill in the PDF, and then once we're done with that, we want to verify it's a PDF, and then everything's okay with it. 0. So the case here that we have 0 would actually be this first one here where they're all tails, and that's only 1 out of the 16. So therefore the probability of getting no heads or all tails is 1/16. And again, the denominator is 16 because that's the total of outcomes in the sample space. Let's slide this down for the next one. Let's look out for if there is 1 heads, and there's ways to remove that. Of course, that's not in any particular order, but you know, in this case here, like heads could come first, then it could come second, third, or fourth, and that's actually displaying all of them there. That we know that that is 4 outcomes out of the 16, and of course we can simplify that to 1/4. Okay, next one for 2. What's the probability that you get 2 heads, and therefore that would imply also 2 tails? Well, here we have 2 heads here, 2 here in the middle, and then 2 there at the end, and then kind of staggered there, and also in this other form here. Looks like we have a lot of them here, and precisely we have 6 of those out of the 16. If we go ahead and reduce that, divide by 2, we get 3/8. Almost done here with this example. Next one for 3. What's the probability that you get 3 heads and 1 tail? It just says 3, but implies that would be 3 heads, and therefore we conclude that there is 1 tails. So that would be here, 1, 2, 3, and 4. So we have 4, or 4/16, and again that goes back to 1/4 as above. And this last one here, what's the probability that all 4 are heads, and there's only 1 there that occurs like that, and here we have it there, and the end there where they're all heads, and that's 1/16. You'll notice here as a pattern, if I go ahead and highlight this, that you'll see the 1, 4, 6, 4, and 1, and let me just kind of stack it here. Let me just do one more row. If you've seen this before, this is called Pascal's triangle, and so it's evident that by Pascal's triangle, the numbers in Pascal's triangle happen to be the numerators for this case scenario. And the reason is because it follows this binomial like idea. And this is kind of leading up to that when we start talking about binomial theorem. The first coefficient of the binomial theorem follows the combinations or Pascal's triangle here. So it's kind of a weird coincidence in that way. But this only applies in a situation where it's like kind of twofold, that it is or is not. And here in this case, it's heads or it is not heads. And that's how we can get Pascal's triangle to emerge from that. You don't need to know that. That's just a little extra information for those that have seen the patterns there for Pascal's triangle. But anyway, here we want to verify, is this indeed a PDF? If I add those all up, I need to get 16 16ths. So we've got here, we can add, basically, you can add in your head here, 1 plus 4 is 5, 5 plus 6 is 11, 11 plus 4 is 15, 15 plus 1 is 16, and we've got 16 16ths there, of course, is equal to 1. And the other thing to verify as well is that none of those probabilities are negative, nor are they over the value of 1, and that's the case for each one of those. So that verifies there that that's the case, and this completes the problem, filling out the PDF for 4 flips of a fair coin.